So welcome guys with another video of our Ccna 20301, and this video I will going to explain the concept of subnetting. So in the previous video we said that our IP address can be from the three classes, and if they're class C for example, then the first three portion must be common between them in order to create a subnet. Okay, but guys, here's a problem. For example, there's an organization. Okay, there's an organization. That organization has only 100 clients. Okay, has only 100 clients, or let's say PCs. This organization wants to create a network or wants to make us their subnet. Okay, what's your suggestion that which class this organization must use? Obviously your suggestion is that since it's 100, so I will just go with the IP address of class C, because class C IP address starts from, for example, if I take the example of 10.network, so this is my network portion, yeah, you know already. So if I take the example of for example, this .1 going to be for one PC, and 192.168, oops, I'm sorry, 192.168.10.2 for other, 192.168.10.3 for other, and like this 192.168.10.100 for the last one. Okay, but if you see, this network still has more capability, still has more capacity. Why? Because it can expand more. 192.168.10.101, because we have in each octet we have 8 bits, and the maximum number can be 192.168.10.255. Now you got it. After this there is no capacity, so you have to change your network. You cannot use this network anymore. You should go for other network, 192.168.11.1. It starts from other network because this network is already finished. So for this organization, which is only 100 PC, you have to use the network of 255. And if there was some other organization, that's company B, for example. This is company B. This company wants, for example, this company needs also 100 client and wants to have its own network. This was company A. So you will ask that, guys, sir, I already used 100, so I want to give the rest for other company too, for company B. For example, I will start from 192.168.10.101. Is it possible? If you watched the previous video, answer me this question. Is it possible if they are from flat A and flat B, they are totally separate networks, but you're using the same network between all of them, they are totally different organization, then how possible you're using the same network of company A to company B? So obviously it's not possible. You have to use some separate other network. So you will ask me that, okay sir, I will use 192.168.11 network, and since 11 is totally fresh and new, I will start from IP number 1. So how many wastage you have here? 100 is used, 155. How many wastage here? For example, if it's 100, then 155, let's say. So you have lots of wastage, and now you consider that if an organization or if a company has only 10 clients, and still the smallest subnet which you are going to use is only class C. Class C provided 255 clients, but still you are wasting. For example, if you are using class B, let's say you are using class B 116.1.1, okay, or you start from the first initial 0.1, then 172.16.0.2, 172.16.0.3, then like this till 172.16.0.255. Then the first block, 0 block is finished. You will start 172.16.1.1. You will start 172.16.1. Like this 255. Then you will shift to 172.16. You will again increase the second block as 2 and start from 1. So for the class C you have 255 address, and for the class B, if you count all the 255 blocks, just 255 into 255, you will cross more than, you will just waste more than 65,000 IP address only in class B, and more like this if you go for class A, for example, .1.1.1, let's say. So it's all the portions can be changed, so more than 1 million IP addresses waste. more than 1 million IP address going to be waste. So what's your solution? For example, a company need 258 clients. You cannot go for class C because class C provides 255, but if you go for class B, then only 258 you need, but you are wasting how many IP addresses? Are you getting the problem? So this is a problem. That's the wastage of IP address. The solution for this has become the solution is subnetting. So what the subnetting means? We are dividing a network into subnetworks. For example, 192.16.1.168.1.1, let's say. This is for the class C, right? So it has 255 IP addresses. I will divide this network, or I will divide this class C into, for example, 4 classes, 4 subnetworks, which, for example, total, if you count total, you have 256 IPs from a single class. You will have 256 IPs. If you start, for example, 192.168.1 is your common, you will start from 0 to 255, right? So that will be 256. So I will divide this into, for example, my company requirement is only 60 IPs, okay? So what I will do, I will divide this 256 up to maximum possible division, that will cover 60. So I will divide, for example, into 4, because each portion going to be C. Calculator, 256 divided by 4. So each portion will be 64. Each subnet going to provide 64 IP addresses. So one of that subnet is sufficient for me. Or if our company, well, like previous company, needed only 100. So if you divide this 250, for example, let's go to calculator. If you divide 256 into 4 again, that will provide you 64. But you need 100, so that's not a good division. Let's go to 256 divided into 3, let's say. That is 85. So 85 is also not possible. So your portion going to be 256 divided by 2. Yeah, now 128. So at least you minimized it. See, you divided the subnet into 2 equal subnets, where every subnet has 128 addresses. Now, how you are doing this, I will explain you. I will just, first of all, I'm explaining you what is subnetting. Now, these 2 equal subnets one of them can be allocated for class for building A or company A, and one of them can be allocated for building B. But so that's called that's equal division of same network into 2 network. How to do that, I will explain you. But first of all, you should know, guys, that subnetting is in 2 ways. What are the 2 ways? The first way is equal subnetting. The first is equal subnetting, and what is the second? Unequal subnetting. The equal subnetting is also called the Flsm. What Flsm means? Fixed length subnet mask. And the second one, or unequal one, is called as Vlsm, or variable length subnet mask. So Vlsm, the variable length. And this variable length, that's really good. See, for example, there are 4 organizations. There are 4 organizations inside a company, and you want to have, let's say, one of the organization requires only, for example, one of the company requires only 20 or 30 clients. Another one requires 100. The other one requires, for example, 64, and the other one requires, for example, 40. So in this case, if you divide a network into 4 equal ports, that for example, and if you divide into 4 ports, everyone will have, for example, 64, which is not sufficient for this. And if you divide it by 2, everyone, you cannot afford all of them. So one subnet or one class is not sufficient. In this type of division, you need to use Vlsm technique, which is to separate a subnet into multiple variable subnets, where every subnet has different sizes. So, but first of all, we will learn how to divide a subnet or a network class from class C, class B, or class A into fixed length subnets. For example, I want to depending upon our requirement. So these are all examples. For example, a company requirement is for example 50 clients. Okay, 50 clients. Before solving this example, guys, I will tell you one thing. That is the concept is network ID and broadcast ID. In every subnet, in every building, or in every network, you know now that subnet, okay? In every subnet, we have two things available. One is network ID and one is broadcast ID. For example, this is our building A. This building has its own network ID and broadcast ID. For what's the network ID? For example, 192.168.1.1. This is a network where this is subnet where the first 3 portions, because of the class C, the first 3 portions is related to the network. Okay. For this network, what is the network ID? The first initial host of this network is called network ID. What's the first initial? 192.168.1.0. Okay, so 1.0, the 0, the first host of this network, which is 0, is reserved for network ID. For example, if I give you another example like this, 172.15.1.1. This is obviously IP address of a host and a network. And which network? And a network where the first 2 portions, because a class C, the first 2 portions is the network portion. So what will be the network ID of this network? 172.15, that's going to be 0.0. So for the class A, what will be the network ID? For example, if your first octet starts from 17, then this IP 17.0.0.0 is your network ID. This IP is actually not assignable for the clients. See, if I want to go, I'm a client, this IP is not assignable for the client. If a client wants to communicate, it cannot use the IP address of, for example, if I use the IP address of this 0, see, it says that it's not possible actually, because the IP address, the 0 is not an IP address, that is a reserved IP. That's the 0 is a reserved IP, which is only your network ID. So you will ask me that what's the use of network ID? The use of network ID is to represent a network. So while I'm writing 192.168.2.0, so what does it mean? It means that this is a network where, for example, it's a building where the building name is 192.168.2. Where the building name is 192.168.2, and the other ports is all the flats 1, 2, 3. Whomever is coming here to take to rent a flat or to buy a flat, so I will give 1, 2, 3. But this, when I'm representing 2.0, it means that it's a network ID is used to just only indicate what's your common portion. If you want to indicate or tell for someone what's your subnet, when I'm asking you what's your subnet, you will tell me 192.168.100.0. Or what's your subnet, you will tell me that 14.0.0.0. But when I'm asking you what's your IP, you will say that 14.0.0.1. So to tell your address location, your building, your location, you will use your network ID. but not for communication purpose. Because if I want to meet you, I will come to your flat. I will not come to your building. If I want to see you, okay? So you will just tell me that my network or my building address is .0. You will just say the network ID. But if you want to visit me within that building, come to 2.1 or come to 2.2. Are you getting it? So the network ID is the portion where it's used for this showing your network, your subnet, your building name. You are related to the which subnet. Okay. So this was network ID. What is your broadcast ID? Broadcast ID is like is the last. Now you got it. Yes, the last IP. 172. For example, this 15.15.255.255. These two ports are related to network, then network, and once they become, both of them has become to the 255.255. That is the broadcast ID. Broadcast ID is related to everyone. For example, in a network of 192.168.2.0, if I want to go to 192, if I want to say hello to 192.168.2.1, so I will directly type the 1. If I want to say hello to 192.168.2.2, I will type the IP address of 192.168.2.2. 1 I will say hello, saying hello, hello 1 to 1, hello 1, hello 2, hello 3. But if I don't have that much time and I want to say hello to all of the users, all of the clients in this network or in this building of 192.168.2, if I want to say hello for everyone, so I will simply say 192.168.2, this building, everyone. Hello for everyone. Or if, for example, there's another example, 192.16. If I say hello for 1, I will say like this. If I say hello for 2, I will say the IP address of 2. If I say hello for 1. For example, if I say hello for 2.5, I will say the 2 like this. 192.16.2.5, I will say like this. But if I don't have that much time to say hello for all 65,000 IPs, I will directly say 192.16.255.255. Hello for everyone. Now you got what is the broadcast communication. The broadcast communication is one to all. So if you want to have a communication where everyone includes, so you will use that network, wherever that network it is. But the broadcast IP of that's like totally a conference room. So if you want to say hello for everyone, just use the broadcast ID. And if you want to say hello for one specific person, use the specific IP of that person. And if you want to know the address of someone, where you're living actually, you will ask the network ID of the person. I will ask that, for example, when I want to know 172.18.230.113, I will ask this person 72.18.230.113 that where are you living? You are a host IP address, because I cannot see any 0 in you. So you are a host IP address. So where are you living? You will say that my building name is 172.18.0.0. This is my building name. And if you want to say me hello specifically, then not come to my building, come to my building, but inside my building, come to IP 230.113. Or if you have you don't have that much time, then directly put your message on the group to 255.255, and I will receive that, because 230 is under range of 255 and 113 is also under range of 255. So I'm there only. Don't worry. Just say hello for this 255. Your message will be received to me. Okay, or your message will be delivered to me. I hope you understand the network and the subnet part, guys. Now we come back to our subnetting concept. So in a subnetting concept, we had two types of subnetting. That was fixed length and variable length. For example, a company requirement is how many address clients? 50 hosts, which 50 actually for only host, or I can say wallet host. But for every network we have one network ID, okay, plus one broadcast also. For every network we must have one network and one broadcast IP. For example, if I say a total complete for class C IP, 168 for example dot 20.0 to 255 range. We have 0 to 255 where 192.68.20.0 is my broadcast. One IP is used here. Sorry, my network. One IP is used, and 192.168.20.255 is also used for my broadcast. So remaining, how many IPs are remain for me? 256 minus 2. So remaining is 254, which can be used valid host, which can be used for communication. These are not for communication. So when a company requirement is 50 valid hosts, you should also consider one network and one broadcast. Without these two, we cannot have a network. We should have these two. We should have our address and we should have our common network. So the actual requirement is 52. Okay? But if a company says, no, you don't worry about this, or don't wonder about this, don't wonder about network and broadcast. Tell me, allocate 62 IP for me. Then it doesn't mean that this company is not taking under consideration of network and host. This company is really smarter than you, and he knows that you also need to add 2 for network and broadcast, so you already added. But this company valid requirement is how many addresses are for valid requirements? Yes, 60 is their valid requirement, because he already calculated for you that 2 are already needed. But if someone is not calculating, so you just need to focus on the documentation, the question which you're reading. If the question says that you need only 50 valid hosts, but you don't need to, but you should also consider the network. But mostly, guys, you will face questions like this. You will not face questions like don't wonder or don't worry about the network and broadcast. The company will ask you that I need 50, I have 50 clients or I have 50 employees, and all of them need an IP address for communication. So you should also add 2 extra on that. Okay. Once now you got to know. Now we will do the practicing of Flsm. Okay. Fixed length Flsm. Okay. Requirement 50 valid plus 1 plus 1. Now you know that. That is 52. This is your requirement. So you have the minimum class which you can have is for 52. So for example, if the requirement was for example 300, then obviously you cannot use class C. You're that much, I know that you're that much smarter that you cannot use class C, because that class C even cannot have 300. After 255, that class C is going to change your network. But if you want to be in the same network and at the same time that network should provide 300 clients, then you should go for class B. Okay, because class B can cover 300 for you. Well, yeah, I can understand that class B is really large class. That's 65,000 IP addresses. But if you want to have the class B 300 clients, which is out of range of class C, then go for class B. Okay, this example which I'm giving you is for a class B. So at the next time I will give some example of class C. So you have class C IP address which provide you 256 IP addresses. Okay. First of all, how to know how to divide this 256 into how many? This 256 should be divided in which number? You should always refer to the power of 2. In power of 2, see the table of power of 2 and find that exact power which matches your requirement. My requirement is 52, and this 2 to power 6 is matching my requirement, isn't it? So 2 raised to 6, which is equal to 64, is matching my requirement for a class C subnetting. So well, yeah, now you got to know there's a formula. Yeah, now you got the data 6 actually. So you directly that's 2 raised to power 6 is equal to 64 number of IP addresses, which covers your requirement. Now what you need to do is you need to divide the subnet like this. An octet has content for how many number of bits? 1, 2, 3, 4, 5, 6, 7, 8. A single octet contains this many number of devices. Your 64 comes till here, means your host starts from here, but it's going to have 1, but you don't need 1, you need more, not 2, you need also not 8, you need not 16, 32, but you need 64 because your requirement is under 64, so you don't need more than this. So till this range everything is fine for you. So what you are going to do is you just count up till here. Till here is enough for you, and you just cross the last one. Add this last one, add the remaining portion to network. Are you getting it? Add the remaining portion to network, and wherever there is a network, that is 1. You know that previously I explained that wherever that's a network, that's 1, and the host portion is always 0. Because if I'm saying that the subnet mask of class C is 255, like this, if I'm saying that 255.255.255.0, so it means that the network portion is all the 3, because they are all zeros, they are all 1s, but the 0 port is a changeable port, that's the host portion. But right now my host portion is not like this, 1, 2, 3, 4, 5, 6, 7, 8. My host portion only need 1, 2, 3, 4, 5, 6, 7, and 8. My host portion only need this much, so I didn't need this 0. I will add this 0 to 1. I will add them in binary. Actually, this 255 is also 1, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, what I did, I only removed, because my range is still here, because 64 is enough for me. I don't need the 128 port to be 0. I just change it to 1, and that's enough for me. I will add them to my network portion. So now when you want to assign IP address for this network, you will assign like this 192. If you want to specify what's your building address, now you will say that my building address or my subnet is 255.255.255.128. This is my subnet address. Okay, once you wrote the subnet as 128, then the computer directly realized that, oh, since it's 128, then obviously this is the subnet. Each subnet for this class is not going to be from 192.168.1.0 to 255. That's not going to be like this, because now you're not 0 in the last octet. You have some number in the last. So it will calculate it, computer will calculate, and he will find that the IP going to be stored 192.168 1.0 to 192.168.1.64. Oops, 64. This is your first subnet. So, and this so we have divided this subnet into see, we will count how many equal subnets going to be there. Till 64, 192.168.1.65 to 192.168.1. Let's add 128. Other subnet going to be 192.168.1.129 to 192.168.1. Let's add 3 64s. Let's go to calculator and add 3 64s. 3 into 64, 192. and the other subnet 192.168.1.193 to 192.168.1.255. Are you getting it right? So now see, a single subnet of class C which has from 0 to 255, now it's equally divided into four equal subnets where each subnet has equal number of hosts. That is Flsm because that's fixed length. Everyone has got their 64 number of IP addresses. Not valid. The valid one is -2 because you should consider two for one for a network ID and one for broadcast ID. So if I ask you that my IP address is 192.168.1.1 and my subnet mask is 255.255.128, like this. So you will directly, and I will ask you a question that what's my network ID? So you will say that 192.168.1.0 is your network ID, and what's my broadcast ID? 192.168.1.64 is your broadcast ID, because your last upper range, the upper range of first subnet, the first initial subnet, port 1, is still 64. And if I say that my IP address is 192.168.1.130 and my subnet is 255.255.128, so please tell me what's my network and what's my subnet. Sorry, my broadcast. This is my IP address. Okay, so you will see and you will directly jump, you will see that their subnetting has been done because the last octet is not 0 as default. So the subnetting is always obviously done. So you will directly see in your all the ports, and you will see that 192.168.1.129 is network ID. Network ID. Okay, so 192.168 and my broadcast ID, 1.192 my broadcast ID. Are you getting it? So I hope you understand this well. So when I assign an IP address of like this in my computer and I go to my, see guys, our IP assignment is after finishing the explanation of all these concepts, we will go and do some IP assignment assigning in our computer. Also you can do like this in your computer if you have. Go to this, go to here, go to IP address and assign an IP address. Just a minute, first I want to assign this IP address, and I want to, for example, this is for company A, that's for company B, for company C, for company D. Okay, so I want to be related to the company. Which company I want to be? I want to be company C, let's say. So I will go to my computer and I will join my computer to the company C. How? I will 192.168.1. One of IPs from company C, for example 130, between 129 to from 129 to 192. So I will type 255 dot what? 128. And here I will have my default gateway. So I know I don't know right now who is my default gateway. I know who is my broadcast. I know who is where is my location, my building or my subnet, which is 129. But here is asking me what's the default. I don't know my default gateway. I'm just pressing OK. I don't know who is my default gateway. So he will not ask you because it's not compulsory to have default gateway, because you may have your own only your own network. You can have your own network. You don't need to disturb anyone else. I hope you understand that, guys, very well. So if you ask me that, see, for all the A company A, B, C, the subnet was going to be the same. See, if I assign IP address from company A, still I'm not changing the IP address. One, for example, 2. Still I'm not changing the subnet. Subnet mask is still from like company C. You will ask me that how the computer knows. How the computer knows that whether I'm company A or company B, because the subnet mask for the both are the same. Yeah, computers are really smarter than us. They know that the first IP always, if there's a Flsm technique, the first IP is always started from, obviously, from 192.168.1.0 to 192.168.1.64. So my computer will know that if my IP, this is my range, 192.168, and this is my IP. this computer or my computer will only communicate till 192.168.1.64 IP address. Okay, so my computer will internally knows that I can only communicate if this is my IP subnet mask .128 and this is my IP .1. So obviously my subnet is getting divided, and since the initial number of a subnet is from 1, from 0 to the initial subnet is from 0, so obviously he knows that I'm related to the first partition. If I have IP address for my computer from 65 to 120, for example 70, so my computer internally do the calculation and knows that I'm related to the second portion of that. In order to practically perform all this, I will do some labs for you guys, but first of all you should just do some calculations. Then later on, during the practicals, just after this lecture, we will have some practicals. So after that we will make assignments of IP addresses for two computers and different subnets. Same subnet mask, but how computer knows, you will see there. Okay. So this was for class C. For example, if you have a class B, for example, requirement is for example 1000. Okay, for 1000 you cannot go for class C, because class C 1000 in the same subnet. Okay, 1000 requirement in the same subnet, in the same network. So class C we cannot provide for you, because class C says after 255 I will change the network address. Okay, so we should go to class B. Class B. For going to that, you should also again watch the power of 2. After 2 raised to power of 7, we have 2 raised to power of 8, that is 256. Then we have 2 raised to power of 9, that is 512. Then we have 2 raised to, still it's not working for us, so we have 2 raised to power of 10, that is 124. Oh yeah, so it's working for us. 2 raised to power 10 is working for us. So here I need 1000 host, valid host plus 2, obviously, because plus 2 is there. So I need need is 1002 IP addresses. Okay, and 2 raised to power 2 raised to power 10 is sufficient for me, which is equal to 1024. This is sufficient for me. So what I will going to do is I will write here the subnet mask. Now here I cannot reduce, actually I cannot add the last octet. I should actually cut some of them from the previous octet. How? See, the default subnet mask for class B is like this, isn't it? Which is equal to 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. This is the default subnet for class B, because I'm using class B. For example, I'm allocating a subnet. What's my subnet? I will use a subnet of, for example, .10.0.0. I will use the subnet. Okay, the default, but this subnet is providing 65,000, so I want to do a subnet. I want to divide it into fixed equal blocks. So I will see this 65,000 IP address, more than 65 actually, IP address going to be divided into how many fixed equal subnets. So what I need, that's 2 raised to power 10 was sufficient for me, because it's 1024 and it's covering for me. So I need 10 0 as a host. 10 0 as a host. So this much is my need. Oops. Yeah. This much is my need. Okay, guys. And this all can be ones. Now you got it. Yes. This all we can what? Can ones. So now I don't need to have 255.255.0.0, because right now I had 2 zeros available, which gave me 65,000 number of IP addresses. But now I'm reducing this as 255.255. You go with network. And this second portion, only first six are going to be from left to right, going to be my network. Calculator, I will add. See, the first 0 from left to right going to be 1, so I will switch it on. Plus 64 is also 1, switch it on. Plus 32 is also 1, so which is on. 16 is also 1, that is 4 1, and after 16 we have 8. Yes, 248, then dot 0. Now you got it? So we increased the subnet mask, okay, and also we added a little bit. See, till here we had 255, almost like 255 from more like from the class C 256 IP, and we just added only 2 extra zeros. Only 2 extra zeros was sufficient for us, which will give us to 1024, and 1024 is covering our requirement. That is, at least still we have wastage. We have wastage actually. You know how many wastage is there? At least we have around 20 IP wastage. And a Flsm technique, okay, in a Flsm technique. Still their wastage is there, but at least we are reducing the wastage. So when I'm writing IP address of my network as 192.10. For example 0.0, but I'm writing IP address 255.255.248.0, okay, then it doesn't matter. It doesn't mean that this IP is having 65,000, because in the third portion something is going to be changed. 258 is there, so you cannot have all your third portion not going to be from 0 to 255. That's going to be from a specific range. Now how to calculate your specific range? I will tell you. Let's calculate it one by one. 172.10.0 from 0 to 172.10.0.255. Okay, 255 is covered here. 172.10.1.0 to 172.10.1.255. So now we got 256 IP here, and first 256 here. That is, I'm sorry, that's 512. We'll extend more. Then 2.0 to again 10.2.0.3. 172.10.4. Sorry, 3.255. So this block gives me 256. This block gives me 256. All of them going to be 1024. So my subnet has been reached. So now, so what is going to be the first my first subnet? My first subnet going to be from where? From 172.10.0.0 to 172.10.3.255. Yes. How to find that next range? 172.10.4. Obviously after 3 we have 4, because this is reached, the fourth octet is reached to maximum. 4.0 to how many? To 172.10.c. How much was the difference between the first block? 4 was the difference or not? 0, 1, 2, 3, 4 differences. So I will add directly here 8.255. 4, 5, 6, 7. Not 8. I'm sorry. 7.255, because if you count the first block 0, 1, 2, 3. Here 0, 1, 2, 3. 4 block. 0 gives me 256, 1 gives me 256, 2 and 3 also gives me 256. That is 1024. So the next block also going to be 4, 5, 6, 7. Other one will be 8, 9. Sorry, comma should be there. 8, 9, 10 and 11. And just likewise continue till you reach 255. 255. You will reach there, okay? You just do it as a homework. So 172.10.8.0 to 172.10.11.255. Yes, you got it. So when I'm assigning an IP address of this 172.10. Let's say 1.1 and 255.255.248. How much was the subnet? 248, yes. 248.0. When I'm assigning this IP address to my computer, now computer in my computer is in which subnet? So you will directly know that now your network is not to first portion. Your network is not this 2. Your network is now changed. Your network is only this first octet can be till 3. Your network is till 3. So your broadcast. What I'm saying is your broadcast is 172, or your maximum limit is 3.255. So my computer will be related to this subnet, which is this subnet ranges 1024 number of IP addresses, which is covering my network. Okay, so my computer internally knows that the first IP starts from 0, so it will likewise after 1024 it will switch its network. So until my IP is from 1 to 1024, my computer is considering itself in the same network with everyone from 1 to 1024. But once it crossed 1024 and IP was something like this, 172.10.4.1, so my computer knows that this is class B, and the class B is 65,000. But since the subnetting has been done to 48.0, so since the subnetting has been done, it knows that the class B is not right now not 65,000. It is divided into 4 equal parts of 1024. So it will count whether this 4.1 is related to the first subnet or second subnet or third subnet. It will directly count. It will start, the computer internally start from 0.0 to for example 0.255, then it will go to 1.0 to the 1.255. It will count like this. Once it reaches 1024, it will stop the subnet. And again it will start, and we will see that 4.1 is here. So it means that the first and second one are not related to the same subnet. Okay, so I hope you understand this concept. You do your practice for yourself, guys. A subnet of, for example, I need a subnet of, for example, 1 lakh IP addresses, for example, to use practice the class A. But guys, there's a recommendation Cisco recommendation is as a subnet must be, it's a recommendation, it's not compulsory, guys. A subnet must not be more than 500 clients. Okay, this is a Cisco recommendation which says that subnet must not be more than 500 clients. So we even don't need to even do subnetting for the class A. But if you want, for example, go for 100,000 IP 100,000 IP range from class A, and you will see how to do that. So the next method, or the other method, I hope you understand this, guys. The next method is what's the next method? That's VLSM, equal subnetting. Okay, so this video is going to be longer, but by the way, I'm going to record this VLSM also here. VLSM, or variable length subnet masking, where a class is divided, class A, B or C, doesn't matter, divided into not fixed, or divided into variable parts, different portions. Okay, different portions. So I will take a pause here for a break. VLSM, we will have an example of VLSM. We will first of all consider a network of 192.168.1.0, which provide for us 256 number of IP addresses, but we want to divide this in variable subnets, not in fixed subnets as per Flsm. So for example, the company requirements for the first company, let's say, is 25 the other company is 40, the other one, let's say for example 60, and for some other, let's say 30. Please make sure that the addition or the sum of all these numbers should not cross more than 256 number of IP addresses, because a class C IP address only can support 256 number of IP addresses. Let's say there are so many subnets, small subnets, where the addition of them going to cross the 256. So what you can do is you can separate them. For example, take 4 to 5 number of 4 subnets, assign it with a class C, and then the rest change their subnet to something else, because by the way your aim is to do subnetting, so it really doesn't matter whether they must be in first 3 portion must be same or not. Or the second solution is that you can go for class C, class B, or class A. So let's assign, actually there's a recommendation before doing the Vlsm that sort out all this data from ascending order, see 60, 40. It's just a recommendation, not a compulsory process. It will help you. First, allocate the enough number of IP address for the largest portion. Then, so the company A requirement is 60. Check the power of 2. The 60 is going to be under range of 2 raised to power 6, which is 64. So our requirement is 60 plus 2. So 60 is our valid host. 2 must be considered for the network and broadcast ID. So 62 is under range of 2 raised to power 6. Let's calculate it. So 255, the 255 going to be same. Only the last 3 0, the last octet, which are all 0, and the normal in the default case 0, 2, 3, 4, 5, 6, 7, 8 in the default case. But here in subnetting we don't need the last 0 of here. Totally the process is exactly similar to Flsm, so there is no much difference. So we just need to add this last octet to our subnet mask. So really similar to that, we will assign here 128. So we got the subnet mask for our first allocation. That's A. The B requirement is 40 plus 2, which is 42. The C requirement is 35 plus 2 equal to 37, and the 8 and the 30 and D requirement is 25, which is plus 2 equal to 27. So let's write the range of IP addresses for a first company or for the department A. Their subnet mask is fixed. I will write it here. The first IP starts with 192.168.1.0, and we are going to have how many number of IP addresses? 64 number of IP addresses. Still we are not having the exact similarity, so still the wastage is there. I'm not ignoring that, but there are some other benefits that after 60 you will see in the 40, the department B. So it will start from 0 to 192.168.1.63. From 0 to 63 we will have 64 number of IP addresses. 2 are the wastage. That's our, we don't have any other option. And the subnet mask is going to be 128. This is for the company A. Let's go for the company B. See, the process there is not much difference till now, but the difference starts from here. The company B requirement is 42. Let's check the power of V. The power of 2. 42 is also still in the same range. So we can the 2 raised to power 5 is 32, which is less than 42. So we have to shift to the other bit. So it's exactly similar to that. The subnet mask for the class B is also same, 255.255.255.128. It's also same, but the range of IP address is different. How it's like that? It starts from 192.168.1. Now the previous subnet ends with 63. Or let's say the previous subnet ends with any number. It really doesn't matter. According to the previous one, we will start. Let's say the previous one starts from ends into 63, so we will solve it from 64. If the previous subnet ends into, let's say, 100, and the next subnet we will start from 101. So here is an optional case, it's just an accidental case that both are same requirement, because the power of 2, we don't have any good option for power of 2 as at 4T. So that's why it's from 64 to 192.168. Just a minute, let me expand this. Yeah, to 1.64 to it's going to be 127, if I'm not wrong. Yes, 127. The subnet mask is still the same, 255 to 55.128. So the class E, that is 35 actually, 37. So I think this is also going to be under case of where was our example? Yeah, it's also going to be under case of 64. Actually, I will make a changes in here so that you can understand this. I will delete this. I will add the requirement of 30 as not 35. I will add the requirement so that you feel some changes how the VLSM is going to do. I will type the requirement of as 20, let's say as 10 or 28 plus 2, which is equal to 30. Okay, the requirement of company C is, let's say, 30. Now 30 comes under power of 2 raised to the power of 5, so that we can do a little bit of VLSM. Otherwise the process is also for VLSM and FLSM is totally same, only that here the range of IP is mattering. Okay, so let's count 255.255.255. Here we don't need the last two, so we will add this 2 into the network port. Okay, so 128 plus 64 going to be add for the network port. Let me check how much it will be the addition of them. 64, 192. Okay, so the dot 192 going to be the subnet. Now let's see the range. How much will what is the range? The range starts from the previous 192.168.1 dot. The previous one ends with 128. Okay, that's why I'm saying you to arrange it from bigger to the lower. The previous one ends from 128, so this will start from 129. Now tell how much? Tell 192.168.1 129 plus 32. See calculator. Let's see the calculator. 129. So to be calculated to fix 128 plus 32, because now we came till range of 32. Okay, we came till the range of here 32. So we will add only this much. 128 plus 32 is going to be 160. So okay, so 192 2.160. But the subnet was going to be 255.255.255.192. I hope you understand it. This was only the difference. There's not any much difference. The process is also like FLSM. The subnet mask calculation is like FLSM. Only the range matters. Arrange it from bigger one, the largest, to the smallest, and wherever the previous subnet ends, just after one IP after that, start from there. And expand your range till your requirement if it is there, but still there is wastage of IP, because you only need to go till power of 2. You cannot go to 40 or, for example, any random number. You should go either till 8, you should add till 16, 32, 64 and 128, because this is the structure of IP address that can be in the power of 2 only, not other number. Okay, because we cannot actually calculate the subnet mask. This is the problem. Subnet mask can be calculated only in the power of 2. See, just to prove it for you, I will show here. And let's get to properties, assign an IP address for my PC, and I will add a subnet mask of not power of 2. Addition of, I'm talking about the addition of 2 numbers. Okay, so if I see 128 plus 64, 192, if I write 193, see, it will give me an error, because it says that it seems that you are adding 128 plus 64, but before the error message is saying that before adding the 32 and 16, 8, 2 and 4 and 2, you're directly adding 1 to 64, because 193 is 128 plus 64 plus 1, which is not possible. We are crossing three middle 5 bits. So this is the issue actually. That's why you cannot have subnetting in fixed range. For example, your requirement is 42 and you should have a subnet mask of 42. You cannot have subnet mask of 42. You can only have the subnet mask where can be found with the addition of consecutive power of 2. So this is the only difference between Vlsm and Vlsm. Let's go for last one. That's 27. The 27 is also in the power of 2. I hope you understand it very well, because 27 comes under 2 raised to the power of 5, because 2 raised to the power 4 is really smaller than that. So the subnet was going to be the same, 192, but the range is different. How will be the range? See, it starts from the previous 192.168 dot. It will start from 1.130. Yes, now you got it. To how many number of addresses? Let's go to calculator and add 192 plus 32 only. Okay, 192 plus 32. So we have 224. Tell 224 192.168.1.224, and my subnet mask going to be 255.255.192. I hope you understand it very well. So can you tell me still? So my all the company requirement has been done, but right now how many addresses still I have with myself free? Yes, the simple process is just to minimize, just to do a minus, like operation, subtraction operation. 255 minus 192. Let's see how much will be the difference of that. So still I have got this many IP addresses free with myself. 192. Yeah, it was 192. Yeah. No, I did some mistake actually, guys. 192 plus 34 is different. 192 plus 34. That is 224. Here it must be 224, not this other. Just to let me erase it. Okay. So that's going to be. Oops. Yeah, 224 is already here. Actually, this was subnet mask. 192 is fine. I just saw the subnet mask as the end of IP address, so it's already fine. Let's do a minus operation. 255 minus 192. So still I have got 63 number of IP addresses available on myself, which I can allocate them for all those networks where their requirement is under coverage area of 63, including the subnet mask and including the network ID and the broadcast ID. So this was an example of Vlsm. I hope you understand it well. From the next video we will start a little bit about the routing concept, and we will do some pingings, and we will check some reachabilities between clients in the same network and clients in other networks. So from the next day slowly we will start with the practicals too. Have a nice time. Bye bye.